Alright guys, so we're going to take a look, a little bit of review of what we've done before, and I'm going to show you something to do with the slope also again today. You have a couple of assignments to work on after you get done. You have homework that you should be turning in, and some of you forgot to turn in your project, so you have a project to turn in. Remember, throughout this video, you can pause it, try the problem, and then wait, and turn it back on and push play. And then you can see the solution. Don't just watch through the video straight through. If you want to actually learn something, you may want to try it first, and then go back and watch the video. Or you can watch the video and learn some things, and then go back through at a slower pace later on. This video will always be available to you. So, without anything more to say, let's go ahead and take a look at the first problem here. Finding the x and the y-intercepts. So, the last couple classes we looked at finding the x and the y-intercepts. So, to find the x-intercepts, you always let y equal 0. So, you plug in 0 for the y. If you do that, that gives me negative 4x. The 13y cancels out, and it leaves me with 26. If you divide by negative 4, that is going to give you x is equal to negative 13 over 2 as a fraction. Or yes, if you go to your calculator and you do 26 divided by negative 4, you get negative 6.5. Math, enter is how I changed it back to a fraction of 13 over 2. But don't forget, you need to write your answer as a point. To find the y-intercept, we always let x equal 0. Meaning we plug in 0 where the x is. Gives me 13y equals 26, because negative 4 times 0 goes away as nothing. You divide by 13. Y is equal to 2. So 0, 2. And then I could use these points if I wanted to. Wow, let's change the highlighter here. That's not going to work if they match, right? I could use these points if I wanted to graph my equation. Or I could also use these 2 points, as they're both on the line. They're solutions to the equation. Or I could even go into talking about something we talked about last time, how these 2 points could be used to find something called the slope of a line. We talked about the rise over run, the change in y over change in x, y2 minus y1 over x2 minus x1. It tells me what the line is doing across the graph. So number 2, we've got a practice problem of finding the slope. To find the slope, you can use your formula. The slope formula again is y2 minus y1 over x2 minus x1. So if you take that formula and you use the points you have, 29 minus 5 over 5 minus negative 3. What is 29 minus 5? 24. What's 5 minus negative 3? 5 plus 3, which is 8. What's 24 divided by 8? 3. Now yes, if we talk about rise over run, that's really 3 over 1, but you can write it as just 3. Just remember, anytime you have a whole number, it's over 1. So, this is what we talked about last time in class, the slope of a line. We talked about how the slope of a line can measure the steepness of the line. and it can measure if the line is going up or down. So if you look at the little half sheet I gave you last time in class, if you weren't here last time, I'll get you one later. If the slope is positive, the line's going to go up. If the slope is negative, the line's going to go down. If the slope is 0, it's going to be horizontal. That means my y values would be the same constantly in my table. If the slope is undefined, that means my x values are going to be the same the whole time. And what that's going to mean is I'm going to get some number over 0 when I find my slope. That's why it's undefined. Please make sure you understand that undefined means you really can't divide by 0. You can't find an answer. That's what happens when your x's are all the same and you have a vertical line. So, we're going to practice a couple more slopes before we head into the topic of the day. So, take a look at this guy. If I take my slope of this one, again you can pause the video if you want to wait and try it yourself. -3 minus 0, y2 minus y1, over x2, 3, minus 0, x2 minus x1. What is -3 minus 0? -3. What is 3 minus 0? 3. So -3 divided by +3 is -1. Now that's kind of a weird number sometimes when you think about the slope. What that means is, if I was thinking about my line would be going, and I'll show you kind of an approximate place where it's at. -3 would be kind of down here. It would be going down 1 over 1, down 1 over 1, down 1 over 1. And so you would get this line that is going down 1 over 1 across the graph. That's what -1 means. Remember, slope is always measured from left to right. So when we say it's going down from left to right, up from right to left to right. Alright? Now, you can also find the slope by using a table. Notice, slope is also called the change in y over the change in x. Alright, so let's take a look at this example over here. What's the change in y? Down 2. What's the change in x? Up 1. Please be careful though, and don't assume that is if you check one of them, that's the answer. Make sure it works for all of them, because remember, linear has to have the same pattern the whole time. So this one goes down 2 also, over 1, down 2, all over 2. That is not even linear, because it doesn't have the same pattern the whole time. You have to have the exact same change in y over change in x the whole time. So take a look at this example. This is going up 4 over 2. Up 4 over 2. Up 4 over 2. That means my slope would have to be up 4 over 2. What's 4 divided by 2? 2. If you were to actually graph this one, and I'm going to go here 0, -2 would be about here. And then I went over here to 2, 2 would be about here. This graph is going to go up 2 over 1, up 2 over 1, because that's the slope. But also notice if I went from here to here, that graph would be going, wow, that was pretty, wasn't it? Let's try that again. Jeez, I'm going to cheat. I'm going to use my line here. This line would be going up 4 over 2. Even though it's going up 2 over 1, up 2 over 1, that's still the same thing as 4 over 2. If you had to make your own slope, meaning you had to come up with a line that had 0 slope. What kind of line has 0 slope? A horizontal line. What's the same the whole time? The y value. So you just come over here to this guy and you make this a y value. Let's say 3. 3. 3. 3. Doesn't matter what this is, 1, 2, 3, 4, because it's going change in y is 0, change in x is 1. That's 0 over 1, which is 0. So if my slope doesn't change in the y's, it's 0. What is no slope? Well, no slope is the same thing as undefined. This is what I was talking about when I said you have a vertical line. That means the x's are the same the whole time. There's no change in x. So you would have something like 2, 2, 2, 2, 1, 4, 7, 10. Doesn't matter. Change in y is 3, but change in x is 0. That means my slope would be 3 over 0. I can't divide by 0, so it's undefined. Well, what about negative 2/3? That means it should be going down 2 over 3. Down 2 over 3. Down 2 over 3. Sorry guys, things kind of struggling a bit. So, give me a number. You start with, say, 0 here. That means the next one would be 3, 6, 9. If you start with 0 here, down 2 would be negative 2, down 2 would be negative 4, down 2 would be negative 6. You just made down 2 over 3, down 2 over 3 for your slope. And if you drew this line, it would be doing that. It would be going down 2 spaces over 3. The final thing that we're going to talk about today is that another way to talk about slope is calling it a rate of change. Remember, slope is how quickly the line is changing across the graph. It tells you how fast something is moving, how fast something is changing. A rate of change compares 2 different quantities that are changing. An example will be the rate at which distance is changing with time. That's called velocity. You have feet per second. Slope is a way to represent the rate of change. Even in real life problems, you can set up your 2 points and find your slope. So, a couple of other little small examples will be things like miles per hour. It'll tell you how many miles you are going each hour. Dollars per hour tells you how much money you're making per hour. That's 2 quantities that are changing. So, just like we did earlier, we have the change in y over the change in x. Well, in real life, the only difference is that we're not just talking about random y's and random x's. We're talking about things like miles and hours, dollars and hours. That's my y's and that's my x's. So I've given you an example here below. This example is parachuting. At 0 seconds, you open your parachute at 2,500 feet above the ground. At 35 seconds, you're at a height of 2,115 feet. Guys, that is 2 points of information. If you think about it graphically, you open your parachute at 2,500 feet, 0 seconds. That's a point. And then you're falling down to the ground 35 seconds later you're at 2,115 feet. That's 2 points on the graph. So 0, 2,500. 35 seconds, 2,115. Now we want to find the rate of change in height. Rate of change is the same thing as the slope. So, I find my slope. Notice you're going to have the change in y's over the change in x, just like you normally do. But it's going to be the change in height. So you do 2,115 minus 2,500. Over the change in x, like you normally do. But this time it's going to be the change in seconds. Now, I can know these are my x's and y's even without understanding how graphs work. If I just think about it, it's going to be feet per second. Change in y over change in x. Let me do that one more time, make sure you understand what I'm saying. The change in y's would be the feet. The change in x would be the seconds. There's nobody in here, in this classroom, that would say seconds per foot. If you told somebody you jumped out of an airplane and you were falling at 22 seconds per foot, somebody would laugh at you. Number one, that's ridiculously slow. Number two, that's not how you talk about the change in height. The height goes on the top. The seconds is on the bottom. So if you subtract 2,115 minus 2,500, you're going to get negative 385. It's negative. I wonder why. 35 minus 0 is 35. If you do negative 385 divided by 35, you get negative 11 feet per second. Why is it negative 11 feet per second? Guys, you're parachuting. You're falling. If it's not negative, you messed up. Let's take a look at another example. You're traveling by car. You leave home at 8 a.m. By 8:45 a.m., you are 36 miles from home. Find the average speed, and here's your clue here. Miles per hour. Miles per hour. Change in y's. Change in x. So my x's are going to be hours. My y's are going to be miles. So if you look at this, it's going to be at the beginning when I leave home. Don't put 8. How many hours have you driven? 0. How many miles have you driven? 0. When you leave your house, you haven't gone anywhere yet. As soon as you get on the road, yes, your clock starts and your mileage starts. So by 8:45 a.m., notice that's not even an hour. That's 45 minutes. So we're going to do a little fraction here. 45 minutes out of 60. Part over whole. You are 36 miles from home. So you leave 0 hours, 0 miles. 45 minutes later, out of 60 in an hour, you're 36 miles from home. Now you can just find your slope, because it's the same thing as the rate of change. 36 minus 0, 45 over 60 minus 0. Yes, I know some of you know that this is 3/4. That's fine. But I just use my calculator. And I do 36 minus 0. Hopefully you don't need a calculator for that. But then you have 45 over 60 minus 0. That gives me 36 over 45 over 60. If you take your handy dandy calculator and you take 36 divided by 45 over 60. Or you can multiply by the reciprocal. You get 48. So what's your average speed over that trip so far? 48 miles per hour. Alright, so let's talk about what if it is $6 for 8 cans. You're going to find dollars per can. So you do $6 divided by 8 cans. 6 divided by 8. You're going to take out your handy dandy calculator. 6 divided by 8.75. So how much per can? It would be $0.75 or 75 cents per can. Same thing if you did 36 ounces per 4.5 servings. And we'll just use S for servings. 36 divided by 4.5. Take out your handy dandy calculator. 36 divided by 4.5. You get 8. So it is 8 ounces per serving. Miles and hours. 1,580 miles in 4 hours. You would end up with 1,580 divided by 4 in your calculator. So you take 1,580 divided by 4. 395 miles per hour. Hike 49 miles in 3 days. 49 miles in 3 days. You take out your handy dandy calculator. 49 divided by 3. 16.33. So we can round that. Approximately 16.33 miles per day. Now you may more likely in real life say about 16 1/3 miles per day. You may not say 0.33 repeated to somebody. But notice you're finding the rate that something is moving. Just like we did here. Just like we did here. So, your work in class today will involve you finding the slope by the rate of change. You'll have this worksheet to go through, and I've even given you some little hints here of how to set up your points right underneath the problem. And then you use the slope to help you find how quickly Sally's hair is changing. How quickly Jack's weight is changing. How quickly the population in South Carolina is growing. That is what the rate of change is, but it's basically the same thing as the slope. So, next time in class, we will be taking a look at some more things with the slope. We're going to be taking a look at how to read slope on a graph, looking at real-world type graphs for the slope. So, for the rest of class, you've got some time to work on the assignments that I left for you. I hope you guys have a great day.